Thank you so much for joining this lesson. We're going to discuss physics, paper 2. This is a question on thin lenses and also curved mirrors. We are told that an object O stands on the principal axis of a concave mirror as shown in the figure below. So figure 9 below is a figure of a concave mirror. Then we have an object O, which is standing on the principal axis. Look at part A of the question. By drawing suitable rays, show the position of the image. Mark the word suitable rays. So when it comes to ray diagrams and image formation, we usually talk about the suitable rays for the formation of images. So we have the most important rays whereby we can have a ray from the tip of the object, which is parallel to the principal axis. Then it moves all the way to the mirror, like that. So this is a ray to the mirror, which is close and parallel to the principal axis. This ray is usually reflected through the principal focus of the mirror. And what is the principal focus? The capital F. So that is where the ray is going to be reflected through. That way. So that is how the ray is going to behave after reflection by the mirror. So this is now just one ray. There is also another ray whereby we say if a ray is passing through, a ray which passes through the center of curvature, that is capital C, will always get reflected through the same path. It will get reflected through the same path. So look at this. If we do a ray this way, if we do a ray like that, we discover that this ray, once it goes through C, it must get back through the same path that way. So you see now, in front of the mirror, according to the behavior of these two rays, after reflection, they are not likely to intersect anywhere to form an image. Therefore, the rays can be seen to be meeting behind the mirror. Therefore, we are supposed to extend them behind the mirror. And remember now, beyond the mirror, we are supposed to use dotted lines. Therefore, we can dot the same ray behind the mirror in this manner. Then we also extend the first one beyond the mirror so that they may intersect somewhere virtually. It's called virtual intersection. Virtual intersection of rays, like that. Then now we can do the image, which is again going to be virtual. So we don't use complete lines for such an image. So where the rays meet, that is the tip of the image. So we can draw the image there, image I, that way. So we have used ray diagrams to show the image formed. Then after this now, let's check the second question. Determine the magnification of the image. Remember, magnification M can be given by two possible methods. Magnification can be given by distance of the image divided by distance of object, or magnification small letter m is given by the height of the image divided by the height of the object. Therefore, somebody can use the heights. The height for this image divided by height of the object it was. You get the same ratio as when you take the image distance. Remember, image distance is where the image has been formed this way. where the image has been formed from the mirror. So this is a V. Then now, where the object is placed, this one will be called small letter U, which is called now the object distance. So object distance, small letter U, image distance, small letter V. So that is how we can get magnification. So using a ruler, you can construct the same. Let us look at part B. And as we proceed with this type of questions, kindly be reminded of our facility here, whereby you can access airtime of any amount for any network, Safaricom, Airtel, Telcom, by just going to your M-Pesa, Lipa na M-Pesa menu. Then there is what you call the pay bill number now, or the business number, 737356. Then the account number is your own phone number. Once you enter that phone number, now you can proceed by entering the airtime you'd like to spend. Then you complete the transaction and you receive the airtime instantly. Remember, you can even buy for a friend, whereby you use our pay bill, then the phone number will be that phone number of a friend that you're buying the airtime for. So please utilize this facility and also invite your friends for the same. Look at part B now. In an experiment to determine the focal length of a lens, which is now converging, a converging lens is also called a convex lens. A group of 4 students collected some data and used the results to plot the graph shown in the figure below. So let's look at the figure whereby this data was plotted. You can see a plot of magnification on x-axis against image distance V on the x-axis. So we can see that the graph is a straight line. Yeah. Using the graph above, determine part 1, the object position when the image position is 45. Remember, image positions have been given. So you go to 45, then we move along that line. At 45, when B is 45, what will be the magnification? So we read the corresponding magnification. So we can see the magnification value here is exactly 3.5. So we can say that magnification is usually given by V out of U. Therefore, magnification of 3.5 is equivalent to V 45 over a known object position, which is now our letter U. Therefore, to remain with letter U, we have to take 45 and divide it by 3.5 so that we get the image, the object position, that is. So 45 out of 3.5, this is giving me 12.86. 12.86, and these are centimeters now. So that is how we work out such a part. Looking at part 2, we are also advised to calculate the slope of the graph. Whenever the question is open about just finding the slope of the graph, it is again advisable for a student to move ahead to attach the units of the graph. Okay, the units of the slope depending on the quantities plotted on the graph. So let us look at the graph so that we may extract a few coordinates along it. Then from those coordinates, we will be able to find what we call the slope. For those who don't know, slope is another name of gradient. So let me pick a few coordinates along this graph. Yeah, I'm choosing these 2 coordinates. So like this, you can see the first coordinate at this point is 31. 31. Then the other one is 54. So now we can get gradient slope S. Change in Y. This is now calculation of gradient or simply slope. 4 minus 1 divided by change in X, 50 minus 30. You see I'm having 3 out of 20. So the slope shall be 3 over 20, giving me 0.15. 0.15. Now, in this case, magnification is usually a ratio. It is a ratio of distances. Being a ratio, we don't expect it to have some units. Now that it doesn't have units, we are now going to rely on the units which are on the x-axis. So from the numerator, we are not having, because on the numerator is where we have change in Y. So we have no units, but on the denominator, we are having centimeters. So we can say 0.15 per centimeter, or simply 0.15 centimeter raised to power 1. Yeah, that is what it means now by per centimeter. We put it well. Centimeter raised to the power of -1. That way. So we are having now the slope. Now that the slope has been obtained, look at now the third question on this. We are taught to find the focal length of the lens, given that magnification M is given by V out of F minus 1. Now, what we're going to do is we're going to relate this equation to the general equation of a straight line, such that Y equals to mx plus c. Now, from these variables and the constants, we shall say if a quantity is plotted on the y-axis and another one on the x-axis, then the value just before x is usually the gradient. And for our case, we call it the slope. Then the value of c is usually our y-intercept. This is now a mathematical interpretation of a straight line. So applying the same on the equation at this point, then we can say that magnification M equals to 1 over F multiplied by B minus 1. So relating now the two equations, we will say whatever is behind V, you know V is the one on the x-axis, M is on the y. So if V is on the x-axis, then its coefficient will be equivalent to the slope. Therefore, we can say that from this, whatever is behind the value on x-axis is usually our slope. Therefore, 1 out of F is equal to slope. So 1 over F is equivalent to 0.15. Yeah, that. Therefore, how do we get F? By obtaining the reciprocal of 0.15. Yeah, that way. So when we obtain the reciprocal, you see now I'm getting 6.666 recurring. So F becomes 6.67 centimeters. I'm following an accuracy of 2 decimal places. So that is simply how you analyze the graphical question. Remember to subscribe to this platform and also to share the link with your friends. Thank you so much.